So, reintroducing the idea here, all right, of set and sets and set theory, okay? So, a set is a collection of distinct objects. Okay? Each object in the set is called and again, do you guys remember this at all? Is this familiar at all? Each object in a set is called an element. Okay, of the set. So a set is a collection of distinct objects. We could also say it is a collection of distinct elements. Right? A set is denoted by writing the elements in braces. Okay, and braces are those like fancy grouping symbols that we use, right? The fancy grouping symbols. Okay, and we'll get some examples here in a second. Okay. The empty set well, why might we call something the empty set if it has no what? No elements. Yeah, exactly right. An empty set, right, has no elements. Distinct objects. Okay. Empty set is a set with no elements. Okay, and that's denoted like this, or it could be denoted like this, or it could be denoted like, I think it could be denoted, actually I'm not going to write that just in case I might be saying that's like the set of the empty set. Okay, so we'll just say that. The empty set is this 0 with like a slash through it, or just a pair of braces with nothing in it, right? That's the empty set. Okay, I know it sounds silly, and it probably sounds silly that we like have to even like name such a thing, but it is. Okay, the universal set okay, it's the set of all elements under consideration. I'm off the screen now. Okay. So the universal set is a set of all elements under consideration.
So the set is
Denoted by writing the elements first. But yeah, the universal set is the set of all elements under consideration. So what do I mean by that? So we could talk about, the set of all real numbers, right? That would be like a universal set because it has every single real number in it. Or that would be a universal set. Right? You can talk about the set of integers, which again is universal because it's talking about all of the integers. Okay, that makes it universal. It's when you start pulling out smaller subsets. So for example, we could talk about the universal set of the integers, but then I could say a smaller set inside of that would be like the even numbers, right? The even numbers is a smaller subset of all the integers, right? All the positive and negative numbers. We can just talk about the even numbers there. Okay. And this one is denoted as like U, a capital U. Okay. Now we talk about these sets and set notation because determining the number of items, determining the number of elements in a set is important for finding probabilities. All right. So identifying, I put that down here, identifying the number of elements in a set is important for calculating probabilities. Okay, so let's talk about a couple sets here and just see what we can come up with. Okay, so let's say here that, just some examples here. Let's say set A is the set of prime numbers less than 10. Okay. Set A is the set of prime numbers less than 10, right? We just talked about what prime numbers were, right? Refreshed our memories about prime numbers there. So this set A is going to be the set of prime numbers that are less than 10. Okay, so the way we're going to write that is A equals, and then we'll make a little brace. Okay. So, what are the prime numbers that are less than 10? What will be in this set? What are the prime numbers that are less than 10? 2, 3, 5, and 7. Okay, that's right. Okay. Okay. Heading home, Mike? Yeah. All right, hope you feel better. Okay. The number of elements in A, right? So when you write n of A, that stands for the number of elements in A. How many elements does set A have? How many elements does set A have here, folks? 4, right? 1, 2, 3, 4 elements. So the number in A is 4. So n of A, number in A is 4. Okay, that's number of elements. Okay. All right, here's a couple more for you to try. Set B is the set of even numbers less than 10. Okay. And set C is the set of numbers less than 10 that are multiples of 4. Okay, so go ahead and do the rest of those. Okay, set B is a set of even numbers less than 10. Set C is a set of numbers less than 10 that are multiples of 4. Okay. So go ahead and write those sets out. Right? Write out what B is going to be. Write out what C is going to be. And then give me the number of elements in B and the number of elements in C. Talk about a few more things with the sets, and then we'll also get into the probability here. 468? 2468. Sorry, I missed the. Okay, and so what is the number of elements in B then? 4, yeah, okay. Okay, what's in set C? 4 and 8, yeah. 4 and 8, and so the number of elements in set C is 2. Okay, questions so far, anything? Pretty straightforward stuff? Okay, so there's a few like relationships that we can also have here between sets as well. So we can also have like relationships between sets. Okay, so think about these right here. And let's see if can I fit it on here? I'm going to try to. Okay, so looking at those sets, all right, we can say, for example, that all right, well, I don't know if I'm going to be able to fit that there. I'll start right here. Okay, so keep those sets nearby, A, B, and C, because we're going to kind of refer to those here, these next little things. Yeah, here, actually, this is what I can do. Question? Oh, you're straight. What's that? Do you need that? Oh, I will need it back, yeah, eventually, yes. Uh-huh. But you can hold on to it for right now. And I can make a copy for you later if you just want to do that too. All right, so, sorry, back to what I was talking about here. So again, we have some relationships, okay? So we can say, for example, that set C is a subset, okay, of set B. And why do you think that is? What about set C makes it a subset of set B? Why do you think that is? Why do you think we call set C a subset of set B? What about set C you think makes it a subset of set B? Yes, okay, yes. Every element of C, okay, is also an element of B. Exactly right, okay? So set C is a subset of set B, okay, because every element of set C is in set B. Okay, and we denote that this way. C is a subset of B. Okay, that's how we denote that. Okay, you'll notice that like the symbol, right? That's like our U that we use, right? But the U is on its side. Okay, the U is on its side like that. Okay, I always thought of it as like C is contained in B, right? So like all the elements of C are contained in B. That helped me kind of remember what that symbol was there. Okay, C is contained in B. Okay. All right, we can also talk about the intersection of sets A and B. Okay. Bless you. And this is the set of all elements that are in both A and B. Okay? So the intersection of sets A and B is the set of all elements that are in both A and B. That are in both A and B. Okay? And the way we denote that, A and then upside down U, and then B like that. Okay? Rewrite these up here just so you have them. Okay, so in our case, right? What is the intersection of sets A and B? Okay, what are the elements that are in both A and in B? What's the intersection of these two sets that we had from earlier? 2. 2, yeah, 2. Okay, so A intersection B is just this set, 2 there. Okay. So the intersection is what two things, or what the two sets have in common that are in both A and B. Okay. The union of sets A and B, okay, is the set of all elements in A or B. Okay? So the intersection, the set of all elements in A and B. The union, the set of all elements in A or B. And you guys know what union looks like. It's A, and then what's the symbol we use for a union? Remember, it's a U. Yeah, it's a U. A-U, B, like that. Okay. So what would this set be then? What's the union of A and B together? What will that set be? What's going to be in that set? A union B. There's A and B, right? Wrote them on the board there for you. You can refer back into your notes too. Right? What is the set? So what's going to be the union of A and B? What are all the elements that are in A or B? What will we write here? 2, 3, 5, 7, 4, 6, and 8. Okay? And that's fine. They don't have to be in numeric order. And I also like that Tatum did not repeat. Okay? You don't need to repeat the 2. For example, 2 shows up in A and B. You don't need to write it twice. Okay? Just once. Okay? Just once. Okay? So there they all are. And again, you don't have to put them in numeric order. If you want to, that's fine. But it's not necessary. That's fine. That's all of our elements there. It takes A and, puts it together with B. Okay? And there's one more here I want to talk about, and that is the complement. Not the complement like my, you're looking nice today. Okay, that's C-O-M-P-L-I-M-E-N-T. This is the complement as in C-O-M-P-L-E-M-E-N-T. Okay? It's like the word complementary, if you remember from geometry, right? Two angles were complementary if they what? Intersected? Nope. Equal the same length? Nope, that's congruent. And angles aren't length, they would be like a measure of the angle, but yeah. Okay, you're getting closer. It has to do with angles and it has to do with a certain degree, yeah. 90. Okay, what about the two angles? They have to what? Add up to equal 90 degrees. There you go. All right, there you go. That's right. So for this one, okay, so when you would find an angle, like for example 30 degrees, right? 30 degrees, the complement of 30 degrees is 60 degrees because 30 plus 60 makes 90, okay? So we talk about the complement of a set, okay? You have a particular set, and then the complement would be everything else that wasn't in the set, okay? So when you talk about a complement of a set, okay, then it's talking about everything else that's not in your set, okay? So the complement of set A is the set of all elements in the universal set U that are not in A. Okay? Which probability up here, which probability that we did from the warm-up involved using the idea of a complement? Which probability in the warm-up here used the idea of complement? Where our answer was, you know, all the elements in the universal set that are not in A. Which idea here, which number, 1, 2, or 3, use the idea of not? Maybe number 2, right? Okay. What's the universal set? What's the universal set for a die? In other words, what are all the possibilities for a die? 6, right? 1, 2, 3, 4, 5, 6. Those are the numbers in the universal set, right? Okay. So not rolling a 6, that's the complement, right? That's the complement of rolling a 6. Okay. So what's the complement of rolling a 6? Not rolling a 6, which is 1, 2, 3, 4, 5. 1, 2, 3, 4, or 5, right? It's all the other numbers in that set. Okay. I'm not going to do an example for that there, but it does look like, it looks like this. The notation looks like this, A to the C, okay, or squiggle A. Okay. So either see it written as A to the C, okay, which A to the complement kind of thing, or squiggle A, meaning complement of A. Okay. All right, so now let's put that together with probability. Okay. There's a lot there. Okay, let's put that together with probability then. Okay. So let's say A, okay, is an event. Okay. The probability of A is equal to the number of outcomes in the event A divided by the total number of possible outcomes. Number of outcomes in the event A, or for the event A, maybe I should say. And then divide by the total number of outcomes, right? Easy enough. Okay, so let's do an example here. And I'll go back to our old friend, the die, the number cube. Okay, so you roll a number cube. Okay, A equals rolling a prime number. Okay, and we'll say B equals rolling an even number. Okay, prime number, B is rolling an even number. Okay. So the total number of possible outcomes, that's also known as the sample space. Oops. So also say AKA sample space there. AKA sample space. Okay. So for a number cube, right, for this situation, the S, or sample space, what are all the possible outcomes of rolling a number cube? 1 through 6, right? So 1, 2, 3, 4, 5, and 6, right? That's our sample space, right? So the number in our sample space, the number in our set, the sample space there, how many elements are there in that set? Oh dear. How many numbers are there in our sample space? How many elements are there in our sample space? 6. So n of s is 6. Okay. All right. So that's our total. That's going to be our denominator, right? All right, let's find then the probability of A. Okay. The probability of event A happening. Well, event A is rolling a prime number. How many prime numbers, again, were there on our number cube? 3, right? 3 out of the total of 6. Right? Or it simplifies to 1/2. What about the probability of A union B? A union B. Okay, remember union, right, we go back up here. Union, okay, of sets A and B is the set of all elements in A or B. A or B. Okay? So A is rolling a prime number. How many elements are in set A? 3, right? And then rolling an even number, how many elements are in set B? There's 3 as well. But we got to be careful, right? Because that it gets there's a number that's repeated in both A and in B there, right? Right, that number 2 is both prime and even. We don't want to count it twice. Okay? So let's think about that. So let's think about A union B. Whoops. Okay, that set is going to be 2, 3, 4, 5, and 6. Okay, basically only 1 is not included there. Okay, so there's 5 numbers on your number cube that are either prime or even. So it's going to be a probability of 5 out of 6 there. Okay, since the set A union B is 2, 3, 4, 5, 6, there's 5 elements out of the total of 6 there. Okay. And then let's do the probability of A intersect B. Okay. So intersection means the elements that are both in A and in B. So what are the numbers on a number cube that are both prime and even? Just 2, right? So it's just 2. And so the probability here is going to be 1. There's only 1 element in A intersect B out of the total of 6. just 1 out of 6. All right, I'll do one more here, the probability of the complement of A. Okay, so let's talk about what the complement of A is. Okay. Well, if A are all of the prime numbers, right, and the prime numbers in this case would be 2, 3, and 5, 2, 3, 5, right, what would the complement of A be then? Okay, if 2, 3, and 5 are A, what's the complement of A going to be? 1, 4, and 6. Okay, so there's 3 elements in that, so it's a 3 out of 6 probability there. Okay, and that's your idea. That's the idea there. Alrighty, questions on any of that? So I know it's a little bit weird because we took this new idea of sets, right? You guys really haven't seen sets too much before, right? And we're incorporating them into this probability here. But it's the same probability is the same thing we've been, you've been doing since probably elementary school, right? Where you just find the number of outcomes, favorable outcomes, right? The number of possible outcomes for event A, for example, and then divide by the total number of outcomes. Okay. Let's try one more example here, and I'll get you guys started on your assignment. Okay, one more example. And we'll do the same kind of steps with it. Okay, so let's say this. The numbers 1 through 30 are written on slips of paper. The numbers 1 through 30 are written on slips of paper. Okay, and a paper is drawn at random. A slip is drawn at random. Okay. Event A is drawing 1 through 10. Okay. And then event B is picking a multiple of 6, or drawing a multiple of 6. Okay? So, what are the elements of set A going to be? Okay? What are the elements of set A going to be? A equals then what? Okay? Event A is drawing a 1 through 10. So what elements are going to be in set A? The numbers what? Yeah, 1 through 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? And what numbers are going to be in set B? Okay, 6. And then, is 3 a multiple of 6? 1's not a multiple of 6 either. Multiples, so multiply, right? So 12, very good. 18, yeah, you guys got it now. Oh, I'm sorry. No, sorry. The event A was drawing 1 through 10. That's only for event A. Event B is a separate event, right? Again, what's our sample space here? Our sample space, like the total possible outcomes, are the numbers 1 to 30, right? The numbers 1 through 30 are written on slips of paper, okay? So these are just the individual, like, events kind of thing. So the probability of drawing not the probability, but the event is drawing a multiple of 6. So 6, 12, 18, 24, and then 30, right? Sorry, yes. And then the sample space, okay, is going to be 1 through 30, but I'm not going to... That's our sample space, okay? That's like the total possible outcomes. Okay, so probability of A. Okay, so what's the probability that A is going to happen here? Well, how many elements are in A? 10 out of how many total possible outcomes are there? 30, right? So it's 10 out of 30. Or in other words, 1/3. Okay. What is the probability of A union B? Well, here let's do a little bit of side work, right? We know what the denominator is going to be, right? What's the denominator for this going to be? 30, right? It's out of 30 because there's only 30 numbers. But let's figure out what A union B is. Okay? Remember that A union B, when you do a union, that means you're just joining two sets together without repeating anything. Okay? So what will A union B have? Well, it's going to have all of A, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it'll have all of B, 6, 12, 18, 24, and 30. Okay, but be careful here because what's repeated between both these sets? The 6. So we're not going to write that twice. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then also 12, 18, 24, and 30. Okay? So you don't want to repeat that 6. How many elements are in A union B? Well, I was going to say, yeah, there's 10 here, 11, 12, 13, 14, I count, 14. Well, and 15 would be right, but remember that 6 repeats, so we only want to count it once. So it's 14 out of 30, which simplifies to 7 out of 15. Okay? All right, let's do 2 more here. The probability of A intersect B. Okay? So, well, let's look. What is A intersect B? What numbers, what elements here are in A and B? Remember, this was A or B. This is A and B. Okay? So what numbers are in both A and B? 6. Anything else? No. Okay? So how many elements are in A and B? There's just one element, right? So 1 out of what? 30. Okay? So you got only one shot out of 30, okay, of drawing a number that is both 1 through 10 and a multiple of 6. Okay? And the last one here. So sorry, this is like example, 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 example. Okay? How about the probability of the complement of A? Okay. Well, let's think about what the complement of A would be. We're talking about all the elements that are not in A. So, well, yeah, start not just 12, let's start back at 11, right? So 11, 12, 13, ... all the way up to 30. Okay? So how many elements is that going to be? I was going to say, if A has 10, right, and there's 30 total, that means there's got to be 20 that are not in A. So 20 out of 30, which simplifies to 2/3. Okay? So just as a little help here with these complement ones, you'll notice that if I take the probability of A and I take the probability of not A, what do these two probabilities add up to be? What's 1/3 plus 2/3? What's 1/3 plus 2/3? 3/3, or 1, right? And so in general, the probability of A plus the probability of not A is 1. Okay? Or if you want to do it another way, you could say the probability of not A is 1 minus the probability of A. So in other words, we don't. If you want to calculate the probability of not A, we could have just done 1 minus the probability of A happening, right? The probability of not A happening is the probability of, well, it's just taking 1, take away the probability of A. It's the, the opposite there. Okay? So something to use there in your calculations. Alrighty. So, for your homework here, I think I'm going to have you guys do numbers 1 through 14 on page 1 through 14 on page 695. I'll say that in a second here. Okay, and that is section 19.1. Okay, 19.1. So you got to get 20 minutes to get that done. All right, so really no, you shouldn't have any homework tonight as long as you work diligently here. Okay, this is a little bit weird, so I really strongly encourage you to at least, try it out and practice it.
Are we done with those?
Get easier. Yeah, we are finished. Yep. Thank you for waiting. Okay, question?
So, do you have a number of chart where you put the book numbers?
I do.
on here?
You need to know what your number is.
Yeah,
Okay, I
because
can tell you.
I can't